Hello guys, so welcome to Blue Tech Empire Python tutorials. So in these tutorials, we are going to be looking at Python variables. I'm going to be following the content on the Telegram channel so we can read through and so I don't leave anything out. So let's get directly into the video. In Python, we have been using variables before, like all the times we're programming. You saw us assigning stuff like A equals to something, B equals to something, and you saw us doing a lot of things. So we have used variable before, but we have never looked at variables in details. So I'm going to show you guys what actually happens when you attempt to create a variable in Python. So I'll be reading from the Telegram channel. If you're not subscribed to the Telegram channel, I'll drop the link on the description so you can see it. And if you haven't read and watched the video on our installation of Python, how you can watch it, I think it's going to appear at the top right. So you can check out the video so you have Python on your computer so that you can follow up with us. So for now, we see a variable serves as a name or a pointer to a particular value or object in memory. So like I said, each time you create a variable in Python, what actually happens is Python, for example, if we say A equals to 10, what happens is Python creates an object in memory and assigns 10 to it, and later on sets A as a tag to that address in memory. I'm going to be explaining that in details later, but I will continue reading. So it says the variable name can be any valid identifier. So I will let me open this right now and let me open ideal Python. You guys, so you understand what I mean. All right. So for example, if we say let's say num1 equals to 10, num2 equals to 20. From the last video, if you haven't watched it, I will advise you to watch it. The last video on introduction to Python, I explained to you about what identifiers are. So normally identifiers can be used for class names, variable names, function names, module names, and a lot of stuff. But when we use identifiers for variables, we usually call them a variable or a variable name. Now, each time you assign a value to a variable, for example, we said num2 equals to 20. And I want you to remember variable names can only contain lowercase letters, uppercase letters, and numbers. And you can also have the underscore attached to it. So, but here is a valid variable name. Remember, we said variable name can't start with 2 or a number. So here is a wrong variable name. You can have this kind of variable. So that's a wrong variable name. So each time you assign a value to a variable, we call that you have declared the variable. It's called a declaration. So, for example, if I say print num3, Python tells me num3 is not defined. That's because we haven't created a variable called num3 before. So now if you say num3 equals to welcome, at this point we can now say print num3. So you see welcome. Now the stage at which we assign a value, in this case it's a string welcome, to a variable name, it's called assignment. So we declare the variable name 3 and we assign the value welcome to it. In most programming language, you need to declare a variable before you can assign a value to it. For example, in other programming language, you need to say you can write num3, for example, num3, and or let's say a new variable new1. But in Python, you can't do that. So right now, I'm going to show you a C source code. See this code I wrote in C. Now, for example, we wrote integer max count equals to 5. In a language like C, you can declare this variable integer. For example, max count equals to 5. You just declare a variable like this, and later on within your code, you can assign a value to max count. later on within your code, you can write max count equals to 5. In such a programming language, we call this the declaration stage, where you just declare the variable. You brought the variable into existence, and later on we call this the assignment stage, where you assign a value 5 in this case to the variable. So we did declaration and later we did assignment. Now it's possible to do the declaration and the assignment on the same line. For example, in this case, we declare the variable max count and immediately we assigned a value 5 to it. So it's just good to understand here is actually two steps. You can declare a variable and you can assign to it. So the initial stage of creating the variable is known as declaration, while when you assign a variable to it is called the assignment. A value to it is called assignment. So what you should notice in Python, you don't have a separate declaration stage. We only have a declaration and assignment. Once you assign a value to a variable, for example, name equals to Dan, Daniel, for example. In this case, Python, we assign a value to name. Python automatically creates the variable and assign the value name to it. So Python helps us to declare the variable. Once we assign a value to a variable that does not exist, Python implicitly creates that value and assigns that variable and assigns the value to it. So I'm going to read the creation of a variable or variable name is known as declaration, and assigning a value or object to it is known as assignment. The equal to sign, this equal to sign you see here, is not like mathematical equal to. It's not like we say name equal to Daniel, like they are equal. No, we are saying assign the string Daniel to the variable name. So the equal to here is known as the assignment operator. In programming, the equal to sign is known as the assignment operator. In this case, we also have another kind of operator we call the comparison operator, which is a double equal to sign. We will see that later on, but I want you to know the single equal to sign is not equal to as like they are both equal. Now, when you use the assignment operator, the left-hand operand or what's at the left hand needs to be an identifier. In this case, it can be anything. We can have, for example, dog equals to 10. You can even have a number, for example, 345 equals to yes. So I just want you to know the left hand operand can be any identifier, and we can even print underscore 345. So I just want you to know the left hand operand should be a valid identifier. So the operand on the left of the assignment operator is the name of the variable, which can be any valid identifier, while the operand to the right of the assignment operator is a value or object stored in memory and assigned to the variable. Below are some examples. So here we see a couple of examples. I will clear here. Let me cancel this. So let's have some free lines. All right, so now let's have counter, for example, equals to 100. We are going to explain this. Remember, here 100 is an integer. We are assigning it to a variable called counter. I'm going to explain that later. We can also have something like distance equals to 20.5. Here we see this a decimal point number in Python is known as a float or a floating point. We can also have a text like this, welcome. You know, here is a string. I explained it in the last video, but I'm going to explain it a little bit here. So here is a string, and we can also have other kinds of variable. We have lists. For example, we can say list1 equals to use square brace 2 for all right. So there is a list, and we can have tuples, dictionary, and sets like we'll be seeing later. So you see this example, we have a variable called counter. We assign the value 100 to that variable. What happens is Python is going to create an object in memory and store the value 100 in it, and later on Python is going to tag that memory address with the name counter. Each time we use counter in our code, Python is going to find the value assigned to that tag. So for example, if I type print counter, it prints 100. What happens? Python created an object in memory and saved the value 100. It tagged that address in memory with a name called counter. So each time we say we use counter within our code, Python looks for the value attached to that tag or attached to the variable name, which is 100. For example, we can say A equals to 2040. We say B equals to 90, and we can say C equals to A plus B. In this case, Python sees a variable name called A. It finds the value within A, which is 40. It replaces A with 40. It goes to B, finds the value 50, replaces B with 50, and now it becomes C equals to 40 plus 50, which should give us 90. So if you print out C, have 90. So that's just an example. So let's move. Now, from the code above, you can see what happened. Now, if you want to check the type of a variable, like I explained, you can be asking, I earlier said, normally, like in a C program, for example, you see we have stuff like integer. Here is the variable type. Each time you want to tell your RAM or your computer to save space for you on the RAM, you need to tell the computer the size of the space to save, because the computer actually works on precision. So you need to give it a specific size of the data you want to save. So in type programming language like C, in this case, we say integer. In most computers, integer is 4 bytes. So you're telling the computer, I want you to keep a space of 4 bytes and name that space max count, or tag it with the name max count. Then later on, you can store variables within that space. If you say max count equals to 5, the computer looks for that space and saves 5 to it. Now, in this case, we said float. We want a variable called scores. We know it's going to have decimal points, so we store it as a float. The computer will actually save about 8 bytes because floats are larger than integers, so the computer is going to save about 8 bytes. So in type languages, you need to specify the size of the variable you want the computer to, or the space of the variable is called a variable type. It actually results to the size because each variable type has a specific size. So each time you create a variable with a specific size, the computer is going to allocate some space of that size in memory. So you may be wondering, how does Python communicate with the computer? How does Python know the space of the variable? Because you don't declare spaces, for example, in Python. Now, in Python, each time you say, for example, counter equals to 100, what Python does is it first checks the value. When Python checks the value, it realizes this is an integer. So Python is going to create an integer object and save 100 to it. And Python is going to tag that object as an integer, which means Python knows it's an integer you're trying to create at this point. So now, if you want to check the type of the variable you created, you can use the inbuilt type function like this, and you can see counter, for example, and you see it said class integer. So indicates Python actually knows the variable type of every value you create. We can even say type distance, for example, and you see it knows it's a float. You saw in a programming language like C, we had to specify float, but in Python, we didn't specify distance as a float, but Python recognizes it as a float. So Python is a bit intelligent to know the variable types. In this case, text1, in this case, Python knows it's a string. If you say type str, for example, or type str, you see str, yeah, Python knows it's a string. So for example, I say text equals to welcome, type text. So you see Python knows this is a string. So each time you attempt to assign a value to a variable, Python first computes or calculates or detects the type of that variable, and it creates an object in memory, and then it later assigns that variable name to that object in memory. So here is an example. We created a variable called counter. We created an object 100, or we assigned 100 to a variable called counter. Python created an integer object in memory in this case. Here we assigned the value 2.50 to a variable called distance. Python knows it's a float. In this case, Python knows this is a string. Here, Python knows this is a string. Here, we said variable equals to true. Python knows it's a boolean. For example, I'm going to show you A equals to true. Booleans can either be true or false, and B equals to false. Now, if you say type A, you're going to see bool. That's a boolean. A boolean number can either be true or false. Type B, for example, you see boolean. So I just want you to know that. Okay, right. So now we also have complex number in Python. For example, we see 2 plus 3j, and we can have a list, a tuple. We are going to see that later, but you can have different variable types in Python. So if you write type for counter, you're going to see ints. If you write type for distance, you're going to see float. Type for text is str. Type for name is str. It's a string. Type for var is a bool. Type for point should be a complex. Let's try that. So we should say num equals to 2 plus 3j plus 8j, and type num. See, complex. So Python already detected. We didn't have to tell Python, for example, if this was a type language, maybe you have something like complex num equals to 2 plus 3 8j in this case. But in this case, Python is smart enough. It's an untyped language, or it's a dynamic type language. So Python detects the type of every variable for us. We don't need to specify it like we did in C, for example. You see, we must specify the types of a variable. So like I was saying, let's continue. So in this case, when you print the type, here are the results. When you print out the type, you actually have the results. So if you print point, it's going to give you complex. If you print list1, let's try to create a list and print the type. List1 equals to 2, 5, and maybe a string. So you can see print, let's say type this one, you have lists. In case of a tuple, you have a tuple, and so on. If you have a tuple, for example, TP equals to use braces for comma 4.5. Here is a tuple, for example. If we say type 2 equals tuple, so Python knows the type of every variable we create. So unlike other programming languages like C, where you need to specify the variable type when declaring the variable, such as integer, like we showed you, integer var1 equals to 10, float distance equals to 20.5, or bool answer equals to false, like I've showed you. In Python, you don't need to specify a variable type when declaring it. An error is generated if you attempt to do that, yes. When you assign a value to a variable in Python, Python creates what is known as an object. I'll be showing you now. An object in memory. Within that object, Python saves the value, its type, and its reference count. I'm going to explain to you what reference count means, but here is a schematic diagram showing that. Now, in the case where we said var1 equals to 200, Python created an object in memory. It detected 200 as an integer, and it's assigned a reference count of 1, which means it has only one tag var1 pointing to that variable. In the second case, we assigned 20.92 to speed. Python actually created a float object in memory. It detected 20.92 is a float because it has decimal points, and it assigned 1, a reference count of 1 to it. Why? Because only the tag speed points to this object. We are going to look at that in more details. If you create a string called mark, Python creates a string object in memory and assign a tag, a variable, a tag name to it, and a reference count of 1 because only name points to that object in memory. So that's just an example. Now, as you can see from the image above, when you declare or assign value to a variable, Python creates an object in memory where it saves the value, its type, and its reference count. All the objects shown above have a reference count of 1. I'm going to explain that to you later on. After Python stores the value in memory, it assigns the variable name to the object or value in memory. So like we said, in the case of a type language like C, if you say integer max count equals to 5, what happens is in this case, Python first creates a space in memory called max count and assigns 5 and saves 5 to that space in memory. It may be, like I said, it's usually 4 bytes and it saves 5 to that 4 bytes in memory. But in the case of Python, it's the opposite. What happens in Python is, for example, if you say score equals to 80 or and score 2 equals to 80.5. Now, in the first case, Python actually creates an object first in memory and it assigns a variable type of integer because it detects 80 is an integer, and then it now places a tag called score on that integer object in memory. Each time you use score, for example, 20 plus score, each time you use score within your program, Python finds the memory linked to score, the memory address linked to score. It goes to that memory address and gets the value. In this case, it was 80. Now, in the second case where we had 80.5, Python creates a float object in memory and assigns the tag or variable name score2 to it. Wherever you use, for example, if you say score plus score2, Python goes to memory, finds the memory location where score points to, it picks out 80, finds the memory location of score2, picks out 80.5, that's the value, and this one becomes 80 plus 80.5. So in that case, if you press enter, you have 160.5. So I just wanted to show you that. So in this case, for example, we have counter equals to 100, distance equals to 2.50, sum equals to counter plus distance. Wherever counter appears in the code, it's replaced with its value, which is 100. So you have sum equals to 100 plus distance here was 2.50. So Python will replace it with the value 2.50. So that's what, each time you use a variable name within your code, Python actually looks for the value in the object it created for that variable name. So here you have 100 plus 2.5. It should give you 102.5. So here is the output 102.5. So let's go on. As you can see, note that the value is not stored in the variable or identifier. Rather, the identifier is used as a name for the memory location. So like I explained to you, in C, in this case, the value is actually stored in the variable in memory. But in the case of Python, for example, in the case of Python, what Python does is it creates an object. Since it detects the type for you, it creates an object in memory and then it tags that object in memory with the name score. So what you realize is the object already exists in memory and the score is just like a tag to that memory object. So like I explained to you now, here is an example. If you say counter equals to 100, distance equals to 250, sum. If you want to find the actual memory location of any of your variable names, you can use the id function. For example, if I say id score, here is the actual address of the memory on the computer. This should be, if you convert this to bytes, it may be about the 10 gigabyte on my system memory or whatever. If you say id score2, you now have a different memory location. So these are the memory location, the actual memory location where these variables or these objects were created. Now, as programmers, we can't memorize this. That's why we need to use a tag name like score. So we are telling Python, save it in whatever memory you like, but when I want to get that memory, I'm going to use the name score. So tag that memory location with score. So each time Python sees the name score, it knows you're looking for this memory location. It goes to that memory location, picks out the value stored there, which was 80. Each time you say score 2, Python goes, finds the memory location attached to score 2, which is two this long stuff. It now goes into that memory location and pick the value stored in it. So you should know the value is not actually stored in the name, it's stored in an object, and the name just points to that object. The variable name just points to that object. It's like a reference to that memory location. So here is an example. If you want to find the memory location, you use the id, the inbuilt id function or id statement. So as you can see, it's difficult to memorize these long memory locations here. Hence, variable names serve as an easy way for us to keep a reference to the location of our values or objects in memory. Technically, when variables name are actually mapped to memory locations or memory addresses such that when you use a variable name, its address is obtained and Python can easily fetch. So this call here just maps to this memory location. Each time we use call within our code, Python goes into that memory location and find the value, in this case, which is 80. Each time we use score2, it's mapped to this memory location. Python goes in there and find the value stored there, which is 80.5. So I just wanted to understand that. Internally in Python, Python records the variable type like I showed you. Python knows the type of all your variables. As a result, you cannot carry out illegal operations. For example, if I say name equal to Sami, and we have let's say we have age equal to 40. Now you know the type automatically of name, it will be str, like we know type name should be type of name should be str. The type of age should be an integer, like we have seen above, age. So now if you try to add name plus age, it fails. Why? Because Python tells us type error can only concatenate str, not int. So Python knows we are trying to add a string to an int, but you can't do that. If you want to do that, like we'll be seeing later, you need to convert age to an str, but it's not here's what you're going to do. For example, you write name equal to um, name plus str age. Yes. All right. So as you can see from this screenshot here, we created a variable called counter, assigned 100 to it, a variable called distance, assigned 2.50 to it, a variable called name, we assign the string John. Now, if you attempt to add counter plus name, getting an error, Python tells you can't do that. If you try to add distance, which is a float, plus name, which is a string, you can't do that. But no, you can add two numbers together. For example, it's normal to add, for example, let's say it's normal to add if you have num1 equals to 40, you have num2 equals to 40.5. You can add num1 plus num2, which is 80.5. It's normal to add numbers. What you can add is numbers and maybe strings or numbers and lists. For example, you can add 2 plus a list. It should not be possible. All right, you can add because they're of different types. They're not numbers, but you should know float and integers are both under the class number, so it's possible to add them together. So like I was saying, Python hardly creates multiple objects in memory. This is very important for us to understand. Python doesn't create multiple objects in memory. Python attempts to save memory by, let me show you what I mean by that. If, for example, we have var1 equals to 30, 40, var2 equals to 40, and var3 equals to 40. What you normally think is Python actually created an object in memory, integer, and save 40 there, assigned var1 to it, and created another object in memory, 40, assigned var2 to it, created another object in memory, integer, 40, assigned var3 to that, or tagged that object with var3. Python wouldn't do that. Why? Because I'm going to show you, let's say we have another variable called var4, for example. var4 equals to 50. Now, what Python does is the first time it creates, the first time it sees var1 equals to 40, it creates an object in memory called an object in memory integer in this case because it's 40. It assigns the value 40 to that memory location and it assigns a reference count of 1 to it. Why? Because at that point, only var1 was tagged to that memory location. Now, when it sees var2 equals to 40, it already has the value 40 in memory, so it doesn't create a new object. It just adds var2 to that memory location. So in this case now, this memory location will have two reference tag. In this other case, it sees var3 equals to 40. It takes the variable, the tag var3 and points to that same memory location where it had 40. So in this case now, the object 40 has three reference counts. So I want you to understand that. How will you prove it? Let's check the address of var1. var1. Okay, here is the memory address. Let's check the address of var2 by writing id var2. You see, it's still the same like the first one. So it shows var1 and var2 actually point to the same address. Let's check the address of var3. id var3. You see var1, var2, and var3 actually points to the same location. But at this point now where we say var4 equals to 50, what happens is Python is going to create a new object because Python doesn't have 50 in memory yet. So see what happens. If we say var id of var4, for example, you see it's different now because Python actually saved that on a new memory location. So from here we see from the code above, you will normally expect Python to create three integer objects in memory, all having a reference count of 1. On the contrary, as an attempt to manage memory space, Python will create one object in memory and will assign the three variable names var1, var2, and var3 to that memory location. It will also set a reference count of the object to 3. The reference count of an object is the number of identifiers var1, var2, var3 that points, or the reference count of an object is the number of identifiers to that object. In other words, we say it's the number of identifiers or variables that hold a reference to that object's memory location. Like you saw here, Python created an object in memory and saved 40 to it. In this case, the memory location is the same for var1, var2, and var3. It shows all three, var1, var2, and var3, are referenced to that same memory location. So that memory location is going to have a reference count of 3. So consider the code below. We have a equals to 50 in this case, a equals to 50. We have b equals to 70, and we have c equals to 50. We have d equals to 70. So as you know from this case, what's going to happen is Python is going to create an object, an integer object, say 50 there, assign the variable name 50 to it, or the tag 50a to that object. In this case, here is a different number, so it's going to create another object 70 and save the value 70 to it and assign the variable name b to that location of the object. In this case, he already has 50 in memory, so he's just going to assign c, the name c, to that same object. So if you write id a and id c, it should give you the same. But now at d, it already has an object 70 with 70 as a value, so it just assigns the variable name d to that object. So if you have id b and id d, in this case, you see they should have the same memory location. So I just want to show you that. Now we move further. So as you can see from the output above, a and c point to the same location in memory. They have a reference to the same object, while b and d also have a reference to the same object. This proves that Python saves memory by not creating duplicate objects. Now there's a term in Python known as mutability and immutability. Now what is the meaning of mutability? Now I'm going to show you from an example here. If, for example, we say var1 equals to 30, Python creates an object in memory and it's an int because 30 is an integer. It has a reference count of 1 because only var1 points to that memory location or that object in memory. If we say var2 equals to 40, Python does the same, creates another object and save the value 40.5 to it. So in that case, now we have two objects in memory. Later on, if we change var3 to, if we create another variable var3 to true, what Python does is Python has var1. Now take note, var1, here we said var3 equals to true, var4 equals to hello, var5 equals to 30. Remember, we already have 30. var6 equals to 30. In this case, var1, var5, and var3, var1, var5, and var3 are going to point to the same 30 in memory. var4 is going to point to its own hello. Here is the memory location for var4. var5 and var6, are pointing to the same 30 we created above. So this object has three reference counts. Now, if we come later on and say var1 equals to 10.2, now var1 was pointing to this memory location before. Python isn't going to change the value of that memory location to 30. It's going to cancel the reference it had between var1 and 30 and instead create a new object. In this case, the new object is going to be 10.2. And in this case, Python is going to create a new object and assign the tag var1 to that new object in memory. And that new object is going to be, I'll show you guys. All right, so as you can see in that case, so I'm just trying to show you here, if you create, for example, if we say, let me show you here, if we say a equals to 10, and later on we say b equals to 10 or b equals to 10, and we say later on a equals to 20. What happens is Python creates an object, saves 10 there, and assigns the tag a to it. Later on, Python wouldn't create another object 10, it just assigns b to that same location. And later on, if we say a equals to 20, Python isn't going to change the value of that object it created earlier. Instead, Python is going to destroy the bond it has between the tag a and that object and create a new object and point a to that new object which now has the value 20. That's what I just want to explain to you guys. If you change the value of a variable, Python cancels the link or the reference it has and point that variable to the new object it creates. Python does not change the value of the object. So we say in Python terminology, we say these objects are immutable. It means their value in memory cannot be changed. But the reference or the reference between the object and the variable name can be destroyed, but the value cannot be changed. So I will soon be ending. I'll be ending at this point. I just wanted you guys to understand the meaning of variable and how you can create a variable and what Python actually does when you create a variable. So in the next video, we are going to be looking at multiple assignments and Python data types. So thank you very much and see you later on.